Some problem is there for uploading, sharing the screen, sir.
Okay.
1 minute, sir. I think. Need to share screen or window, sir?
It's not visible.
Yes, sir. 1 minute. Is it visible, sir, now? Screen, is that visible now?
Yes, visible, sir.
Okay. So participants, sorry for the delay. First of all, please open the file 3A, coding multiple response variable. Please open the file 3A, coding multiple response data. So this is very, very important analysis we are going to go. And most of the survey related research, we do come across with this kind of data. So please open the file. Have you all opened it? 3A.
Can you repeat the file name, please?
3A, ma'am. Can you please see my screen, ma'am? Is that visible to you? The screen?
Yeah. Screen is visible.
Okay.
Yes.
So the file name is there, 3A dot coding multiple response data and frequency analysis. Have you all opened it? Yes, sir. Okay.
Yes, sir.
So I will explain why the multiple response analysis is very important and what condition we can use it, the application of this. So when you conduct a survey related research, yesterday also we saw some survey related data. Sometimes in a survey related research, we ask one question, the respondents to give multiple options, multiple answer for a given question. Say yes or no? Have you come across this kind of questions in your survey related research?
Yes.
One particular
Sir,
question you
in
may
the
ask,
Google form when we have checklist.
Yep. So we ask them to choose multiple options. So I'll give one example. Imagine that you have conducted one survey, study, research, like what purpose do you go to bank? What purpose do you go to bank? This is one of the questions related to the customer satisfaction related study in banking sector. So one question is, what purpose do you go to bank? What purpose normally we go to bank? There are several reasons. And also depends upon the study, where the study was conducted, population. Some people, they may not use internet. So nowadays, everything we do transfer through online. So that also can be studied, how the internet development in a particular rural, in a place, in a district can. So in this study, one researcher has given around 9 options: deposit, withdrawal, update, inquiry, avail loan, repay loan, locker facility, check deposit, and for availing DD, demand draft. 9 options were given for the questions. So among the 9 options, each candidate, how many options they have chosen? Right? So in the question, if the respondent has chosen means you give yes. If the respondent has chosen means you give yes. Let's say first option is a deposit. The first candidate not chosen. Withdrawal also not chosen. Update also not chosen. No. Inquiry, the candidate chosen. Availing loan, the candidate no. Repay loan, no. Locker, no. Check deposit, the candidate goes to bank. DD, no. Agree? So this is the first candidate, first customer, second customer, third customer. So each of your option, you need to create one column in SPSS. Each of the sub options in a particular question, you need to create one column as a one variable. Say yes or no? Go to variable view. Go to variable view. Can you all see my screen?
Yes, yes, we can.
Yes, sir.
Variable view, is that visible to you?
Yeah.
Okay, so there are 9 options. 9 options. Deposit, withdrawal, update. So each option you need to create, we need to consider as a 9 different variable. And this is what we need to code. If the candidate has chosen the particular option, you give 1 or yes. If not, you give 0. Yes or no. Agree with me? Have you all done? Understood? Have you all understood?
Yes, sir.
Yes, sir.
Okay. Okay. So how do we analyze this kind of data? So that we come to know finally how much percentage of the people they go to bank for availing loan. How much percentage of the people they go to bank for what you call withdrawal money. Whether the internet development, online banking, is it reduced physically going to bank, or still the particular the study was conducted in a place, still people are not rely on using the internet or online banking. We can also study several questions. We can assess the people nature as well as the banking services. Okay, so how do we analyze it? Please go to analyze. One minute. Participant, please go to analyze. Multiple response. Please go to next to survival. Multiple response. Deal with me. Then you select define variable sets. Define variable sets. I'll repeat again. Go to analyze. Multiple response. Define variable sets. Click on it. You will have one new window. Participant, please put your audio in a mute mode. Some of you noise. Participant, please put your audio in a mute mode. Hello. Participant, please put your audio in a mute mode. Some of you creating a noise. I'm having difficulty. Okay. So do you all have this window? Say anyone, please
Yes.
say yes or no.
Yes,
So what
sir.
do you need to
Yes,
do?
sir.
Yeah.
So using
Sir.
the mouse and pressing shift key, you transfer all of your 9 variable into this arrow. Click on this arrow. Select all of them and put it here. All right. The next step, can you please see there is a dichotomous. The counted value, we have to keep it 1. Why 1? We are going to count how many yes are there. Each option, how many yes are there. So yes, we coded with 1. Agreed? And then we need to give a name. The name can be purpose. The name can be purpose. The label can be purpose of visiting bank. Is that okay? Have you all done it? So very, very important.
Yes, sir.
Excel, this is a little bit complicated, but this can be very, very easy.
Yes, sir.
Using this. So once you've done this, transferred all the variable, dichotomy is 1, name, purpose, label, purpose of visiting bank, click add. Click add. So that the set, the multiple response sets we have created. We have defined the multiple response sets. So until now, so far, okay. Shall we move on? So once you've done this, just close it. Once you've done this, just close it. We have a long way to go.
Sir, please repeat it once again, please, sir. After purpose of visiting bank, what we need to do?
Purpose of visit, ma'am. You have to add. Click add, ma'am. Click add.
Okay, sir. Okay.
Click add so that your purpose will be in the multiple response sets.
Okay,
You
sir.
will see your purpose in this last column. So once you've done this, just close it.
Sir,
Just
why?
close it.
Yes, sir. It is.
Sir, why 1 is written in the counted value?
Reason, ma'am, we have coded with 1 and 2, 1 and 0, sorry, 1 and 0. Maybe you can click this data view. You will see yes means 1, no means otherwise right answer, wrong answer. No, the candidate chosen means you give 1 mark. Not chosen means 0. So 1 and 0 we have coded. So we are interested in counting how many yes are present, how many 1 are present. Is that okay?
Okay.
So how many options, how many 1 are present? Inquiry, how many 1 is present? Repay loan, how many 1 is there?
Got
For
it.
that reason, we okay. So click analyze again. Go to multiple response again. Now you can click frequencies. Now you click frequencies. You feel very, very simple. But analyzing this data manually, computation very, very difficult. Frequencies. Do you all have this window? Do you all have this window? What do you need to do? You transfer the purpose from left side to the right side by click on the arrow. Very, very simple. That's it. Click OK. Transfer purpose from left side to right side. Click OK. Please go to the output window. Please go to the output window. Do you have a table? Yes or no?
Yes, sir.
Yes, sir.
So it says that.
Yes, sir.
Says that
One,
there are
one is
330.
case summary.
Another one is a purpose frequencies. Purpose
Right, sir.
frequencies. So your purpose is here there, and the percent of cases in the last column we have to consider. So it says that out of 332 candidate, 50.6% of the respondents have chosen cash deposit. So tell me which options they go to bank. The last one. Which options most of the customer go to bank?
Cash deposit.
Cash deposit more, followed by
Inquiry.
Enquiry, we have to go to bank physically. Most of the banks, they prefer enquiry, means they prefer physically. Cash deposit also have to go.
Cash deposits.
Yeah, cash withdrawal around every 100, 36 people only go to cash withdrawal. Remaining all, they go to ATM. Update passbook, nowadays people are not going to bank. Only 9% of the people, maybe some aged people, they may not have the internet banking. Is that interesting? Is that interesting?
Yes, sir.
Repay loan, only 9.3% of the people go to repay loan. Why? Maybe they will cut from your account directly. Locker facilities, 21.7%. Check deposit, 32%. Maybe business people, they may go to bank frequently. So this is the way we need to conduct a multiple response frequency analysis. So participant, please double click the table. Just to double click the table, using your mouse, you select the categories. Double click the table is activated. Then using your mouse, you select the last column, only the values. Then right click. Can you please see there is a create a graph or bar graph? Just to double click using your mouse, and then the last column you select, then right click, you create a bar. So you can go for a table like this, or you can go for like this bar chart. But still you can improvise the quality of the graph. Bar chart. Please tell me, have you all got the bar chart?
Yes, sir.
Yes, sir.
So you also can remove these grid lines not needed. You also can add the data labels. When you double click the graph under the chart editor, We can also add the show data labels. Close it. Close the graph. So your graph is ready now. So instead of this particular table, you can go for this graph, somewhat interesting. Is that okay?
Yes,
Is
sir.
that okay? So still you can also
Yes.
edit. Still you can also edit the graph. The what you call the label, x-axis label, something lengthy. Double click the graph, wherein you can edit each case. Each case you need to edit, delete. Select this. This all can be removed one by one. Update passbook. So this all some shortcut. Improve the. Just double click the particular axis. Avail loan. This all can be edited one by one. Is that okay? Is that all
Yes,
right?
sir.
So shall we move on to the next exercise? Just you can copy this graph and you can go for presentation. So there were inquiry and cash deposit were more respondents. The least one updating passbook and repay loan.
Wanted.
Okay, cash deposit and inquiry, most of the people they do go to bank. Participant, please put your audio. Participant, please put your audio in a mute mode. Some child is playing with, please. And most of the online session actually, they mute everyone. But when you conduct such programs, may not be useful, may not be interesting. Okay, so may not be interesting. So hence, the organizer, they have allowed everyone to. Organizer, everyone to. 1 minute, some call is coming. All right. So please, common forum, we have to be very careful. Knowingly, unknowingly, sometimes you do mistake. But please always put your audio on a mute mode so that there won't be any noise and disturbing others. Okay. Please go to the next question is. Yesterday we have done it. Normality checking also we have done. We have conducted one sample t-test, independent sample t-test, paired sample t-test we conducted. Please go to Way Anova. 8A1 training course data. Please go to 8A1 Way Anova training course data. Have you all opened it?
Yes, sir.
So when we use Way Anova, what is the purpose? What is the purpose of when do we use Way Anova? So when you are comparing apple versus orange, comparing the mean value for a numeric data, we go for independent sample t-test. Do you agree with me? If it is more than two groups, comparing the mean of population, we have to go for analysis of variance. Got it? Participant, have you all got it?
Yes, sir.
When you are comparing more than, for example, you have three group of students in your university. You have a business program, you have a biology program, you have a chemistry program. After completion of the undergraduation, after 5 years, you are assessing the student, which program student they do get more salary. Whether commerce student after graduation, after 5 years of graduation, do they get more salary? Or chemistry students, are they getting good salary? Or biology students, are they getting good salary? So comparing three group of people. Agreed? So this kind of scenario, we are going to go for comparing 3 means we need to go for analysis of variance. So this particular exercise I have given you is about a training productivity data. Imagine that one company, they wanted to send their employees for training, improving their efficiency. But they do not have in-house training. They look for outsourcing. But outsourcing means the company, they do offer a variety of programs. They do have 3 modules. Accordingly, the training fees also vary. They are calling beginner module, intermediate module, advanced module. Imagine that beginner module 5,000 per week per candidate. Intermediate module 10,000 per candidate per week. Advanced module they are charging for 20,000. So the manager of the company who is interested in sending their employees for training, who doesn't know which module is effective, sending them for advanced is effective, or beginners itself is enough for improving the productivity. So everyone nowadays is a profit oriented. So spending more, is it worth, or spending less, is it worth? So what he did, the manager, he recruited 30 employees from his organization. So he wanted to conduct a study or experiment. 30 employees he recruited. Randomly he split the 30 into 3 groups, 10, 10, 10. So 10 candidate, he sent them for beginner module. Another 10 candidate, he sent them for intermediate module. Another 10 candidate, he sent them for advanced module. So all 30 of them gone for a training. Once they have completed the training, they have come back, but the manager is interested in which program is more effective. So what he did, he gave a kind of exercise for all the 30 candidates, similar exercise, some kind of problem solving, how fast they finished the task. If they are very productive, they may finish it very fast. If the particular training is very worth, means they finish it very fast. Okay, so 3 modules, and the manager, he recorded only the time duration they have taken to complete the task after the training. So on average, the time duration is very less, the particular program is good. Is that right? Is that right, participant? Is that right? So comparing beginner with intermediate with advanced, comparing the mean value, time is the dependent variable, course is an independent variable. So effect of 3 different modules on the performance of employees after the training. So please tell me, how do you state null hypothesis? How do you state alternate hypothesis for this study? How do you state null hypothesis? What is your research hypothesis?
There is no
Participant, anyone?
There is no significant impact of type of training on employees' performance.
Excellent, ma'am. Excellent. Excellent. Very good.
Sir, you're not audible. Can others hear the resource person?
No.
Yeah, I think there is some issue. Yeah. Thank you.
So you're not audible.
Is there any SPSS screen visible?
No,
No,
ma'am,
the
there
screen
is
is unshared. But I
No.
think he has left
I
and
think
will
there is
be
an issue
rejoining.
from
Screen is
their
not
side.
visible.
Okay, thank you.
Screen is not visible.
Has sir given us any assignment as of now?
Oops, nothing. Would anyone of you share the recording of the session at the website as the coordinator had mentioned in the common WhatsApp group?
Yes, ma'am. The first day record is shared. I think they shared the link in WhatsApp group.
Okay, and not for yesterday, if I'm not wrong.
No, only the first day.
Okay, so could you okay, did you access it at the website only?
I access it from YouTube. I downloaded it
YouTube.
yesterday.
Okay,
Yes.
okay, thank you.
Thank you.
Have we been assigned any assignment as of now?
No, nothing.
Okay, thank you. Thank you.
Do we have the link of the YouTube? What do we type over there?
Yeah, I think
Yes,
some
sir.
link has been shared, Mr. Nangeli shared. So, sir, if you
Yes,
can
No, that was
put
just
in
for
the
the
group,
first
it will
one.
be
I will
That
forward
was
it to
just
you.
for the first
I will
one.
forward it in the group, ma'am.
sure.
Yeah,
So nice
that's-
of you. Thank you.
Thank you.
Hello, sir. Kindly please share yesterday class recording also in the group.
Yes, today I'll send the link.
Okay, thank you. Thank you.
It's in process. I think Sunil has uploaded or downloaded, and you'll share the link. I'll share it with you.
Okay, thank you. Thank you.
Because we miss out on certain things due to network issues. So in that case, if we have the link, we can go through it and we can get the basics.
Yes, ma'am. Yes. Yes, ma'am.
So there is a network issue from Professor Marimuthu. So he suggested to wait for a few minutes.
Participant, can you all hear me?
Yes, sir, you are audible.
Okay. Please. I have some internet difficulty in my apartment. Something went wrong.
Okay, sir. No problem.
So So reconnected now. So have you all understood the concept for ANOVA? Now can you see my screen? Is that visible?
Yes, sir.
Okay. Okay. So training we have arranged in one first column. The time they are taken to complete the spreadsheet program or the task given in the another column. So we're coded with, there are 10 candidates for beginner, 10 candidates for intermediate, 10 for advanced. So total 30 candidates. So how we need to code? Click on this. Below help, there is a value label icon. So 1 means beginner, 2 means intermediate, 3 means advanced. So 10 times 1, 1, 1, 10 times 2, 2, 2, 10 times 3, 3, 3. In the variable view, were recoded with the variable view recorded with 1 means beginner, 2 means intermediate, 3 means advanced. Is that okay?
Answer for ANOVA, the data size has to be same for all the groups.
Not compulsory, ma'am. Not compulsory.
Not compulsory.
Not
Okay.
compulsory. Depends upon the study. Yeah, not compulsory.
Right.
You
And
can also
same
run.
applies for two-way ANOVA also.
Yeah, yeah.
Okay, thank you.
Okay, okay. So how do we analyze it? This kind of data. So shall we go for some graphical illustration first, then we move on with ANOVA? Let us see. Go to graph. Go to graph. Chart builder. Click on chart builder. I don't know. A lot of delay in my system today. I don't know. Something went wrong. Let me close. Is there anything is open? Click on chart builder. Graph. Have you all got it? The chart builder.
Yes, sir.
So you need to pick up the first one from the bar. Leave it here. And then the training supposed to put it in the x-axis. Time duration should be in the y-axis. This problem in my laptop. Okay. So click on display error bar. Standard deviation 1. Standard deviation of 1. Multiplier of 1. Agree? Then click OK. Your graph is ready. Please tell me whether you got the graph.
Sir, what we have to do after labeling it for standard deviation, what we have to click?
1, ma'am, the multiplier 1. Multiplier 1, then click OK. My system today is slow.
Hello, sir, can you do it once again for me?
Yes, ma'am. Yes, ma'am. I'll repeat. 1 minute. Give me a second.
Okay. Thank you, sir.
I think I have a. I'll repeat again. Go to graph, chart builder, reset. I will do from the beginning. Click bar, first one. Drag and leave it in the different types of training in the x-axis. Time duration in the y-axis. Go to display error bar. Standard deviation multiplier with 1. 1 time standard deviation will be displayed in the error bar. That's it. Click OK. Click OK. So you will see a graph in your output window. Please tell me, have you all got the graph? Participant, please tell me, have you all got the
Yes,
graph?
sir.
Yes, sir.
So you can also you can remove these grid lines. Normally the graph title should not be there in the title itself. You can also remove that. Double click the bar chart and remove the title. That's it. So graph is ready. So title can be deleted by selecting the particular line and delete. Close it. Yeah. So now graph is ready. You can just right click and paste anywhere if you want to go. Okay. Shall we run the ANOVA? Shall we run
Yes, sir.
ANOVA? Go to analyze. Go to analyze. Compare means. Can you please see there is one way ANOVA at the bottom, the last one. Analyze, compare means one way ANOVA. Just click on it. So here in this window, we need to transfer the types of training course in the factor. Your dependent variable should go into the factor. Time should go into the dependent list. Independent variable should be in the factor. Time duration should go into the dependent list. Agree? Have you all done?
Yes, sir.
The next one, click options. I do need descriptive statistics. I do need descriptive statistics to explain the data. And then click on post hoc, continue, and then click on post hoc. A couple of multiple comparison, A versus B, A versus C, B versus C, multiple comparison. Beginner with intermediate comparing, beginner with advanced mean we can compare, intermediate with advanced the mean we can compare.
So can you please repeat? I completely lost my connection.
Okay, so we have a long way to go. I don't know how I'm going to complete. Okay, so shall I repeat, participant? Those who are completed, please do wait. Those who are completed, please do wait. Otherwise, the particular candidate cannot complete the exercise. Please do wait. We'll reset. To analyze, compare means one way ANOVA, wherein in this window, transfer the course into factor, time duration into the dependent. Once you have done these two, click on option. We do need descriptive statistics. Click options in the window, click only the descriptive, continue. Then click post hoc. The post hoc is meant for multiple comparison. Post hoc is meant for multiple comparison, meaning to find out which training is more effective. Whether all the means are different or a particular training is more effective, we can find out using the multiple comparison. I'll come back to you how to interpret these results in a nutshell. So I can choose 2 keys multiple post hoc test. Click on 2 keys. There are many. I'm going to use the 2 keys. Continue. Then click OK. Your output will be ready. Some delay in my SPSS. I don't know. Maybe I need to close them and it takes time. Please bear with me.
Sir, that is 2 keys B or 2 key only?
2 key, ma'am. 2 key. If you use that, also nothing wrong in that. You can use. But methodology, you have to spell out what post-hoc test you have used it. All the what you call the first the section is equal variance assumed post-hoc test. Nothing wrong in it. Anything can be used.
Okay, sir. Thank you.
So we have a couple of tables. The first table is meant for the descriptive statistics. So beginner, there are 10 candidates. The average is 27.84 minutes to complete the task. Intermediate 24.21, advanced 23.75. So I have also mentioned beginner module per candidate 5,000 rupees per candidate per week. Intermediate module, the charges are 10,000 rupees. Advanced module, they paid each candidate 20,000 rupees. So now tell me which module looks good based on the mean value. Which mean value is, which training module is good? Anyone?
Sir, from where are you accessing the money spent?
Advanced.
From the mean values?
Based on the mean value, how do you say that which one is good?
Okay. Okay.
Sir, the beginning one is
Beginners. Yeah.
No, ma'am. Actually,
Beginner
lower the
version.
So advanced one would be better.
I
as
I
it
think
is
the
taking
third
less
one,
time.
the advanced one.
Since it is taking less time for their performance.
Advanced one, yes.
100-meter running race. Who comes first will be the best, right? So the duration is very
Yes,
lowest
less
duration is the
time.
best one.
Yeah.
Okay,
Then
so
it is
depends
advanced.
upon the hypothesis, depends upon the scenario, we need to make the conclusion. So lowest one is the best. Lowest time duration is the best. So now, next question is, the intermediate is 24.21 minutes. Advanced is 23.75 minutes. Paying for additional 10,000, is it worth? Paying for additional 10,000 rupees, is it worth? Statistically, paying for 20,000, is it significantly higher or better than the intermediate? For that, we are going to go for comparison. So you have been given with a mean, standard deviation, confidence interval, minimum and maximum. Fantastic. So this table only you capture in your thesis or your paper. I will explain you later. Now, look at here. This is Anova table. What does it say? What does it say? Null hypothesis we stated the time duration for the beginner, intermediate, advanced are equal. But p value less than 0.05. So what conclusion we can make? The time duration statistically not equal in all the 3 modules. So we have in favor of research hypothesis. So reject the null hypothesis, whatever we stated. We say that the time duration in all the 3 modules are significantly not equal. Yes, not equal. Now we need to look for post-hoc comparison. Post-hoc comparison. Look at the multiple comparison. Beginner with intermediate. How much difference is there? Around 3.63 minutes the difference is there. Beginner with advanced, how many minutes the difference is there?
4 minutes.
4 minutes the difference is there. Okay. So significantly we could see there is a difference in beginner and intermediate. So intermediate is better than beginner significantly. And then comparing beginner and advanced, advanced is significantly better than the beginner. Now look, intermediate. Look at the row, the p-value. What does it say? What does it say? This difference is there between intermediate and advanced around 0.46 minutes. Only slightly negligible difference. Intermediate and advanced 0.46. This could be due to chance also. So the p-value greater than 0.05, greater than 5%. Hence, we can conclude that intermediate and advanced statistically paying for 10,000, paying for 20,000, there is no difference in terms of completing the task. duration. Do you agree with me?
Yeah.
Do you agree with me?
Yes, sir.
So, what conclusion we can make from this? Which module you prefer to go? Which module you prefer to go?
Intermediate.
Intermediate, sir. Reason: paying for 20,000, paying for 10,000, same benefits. Which one you normally prefer? Cost benefit. So intermediate can be recommended, or intermediate and advanced statistical difference. So in the future training program, the manager will send his employees for intermediate program. Is that fine? Is that fine?
Yes.
So now, how do we present this table? How do we present this table in a nutshell in a research paper? I will explain you. Please copy this descriptive table. Copy this descriptive table. Control C. Open an Excel file. Open an Excel file.
So what will be the interpretation of minus 3.63 like in intermediate and beginner?
Second, ma'am, the difference between the two group, ma'am. The mean difference.
Yeah.
The mean difference between the two group. The difference between the two group. Intermediate and beginner, this much difference.
So like in intermediate and advanced, there is a difference of 0.46 only.
Okay.
Very slight difference. So we can say there's no significant difference. The significant value is 0.816. So this is the right interpretation?
Yes, ma'am. That's what. Intermediate and advanced.
Okay. And what about the interpretation of intermediate and beginner, sir?
See the p-value?
So yes, that is okay. There's a significant difference. So it means which one is taking less time, sir?
Intermediate is taking, ma'am.
Okay.
Intermediate taking less time. Around 3 minutes lesser than the beginner.
Okay.
Look at the intermediate. Beginner is 27 minutes, ma'am. Intermediate 24. So 3 minutes difference is that. So intermediate, lower the duration, the particular module is good. I hope I have answered your question.
Yes, sir.
Okay. So open an Excel file, copy the descriptive table, and paste it there. My system is giving a lot of problem today. I don't know. So this morning I've been working. Please open an Excel file and paste it. I need to format my laptop. Sorry for the delay. So I will explain you how to format this Anova table for a research paper. Open an Excel file and copy the descriptive table. Go. So once you're done, just you can paste it here. Copy the table, go to the output window, copy the descriptive table, copy this. So when you copy, the table will be in yellow color. So that you'll get copy this, open the Excel file, just paste it here, Control V, and then you also can open another table, F table, Anova table, this one, copy this, paste it here, For us, these two, the minimum maximum is not needed. For us, the minimum maximum is not needed. You can type F value. Here you can type the P value. So this F can be, you can put it here. This P value, you can copy and paste it here. So this you can merge. This you can merge. This you can merge. This also can be merged. The total is not needed. The row can be deleted. And then you can go for formatting the table. Formatting the table. Usually APA format, bottom. Sorry. APA format, bottom, top. This can be this also can be. So this all can be in bold. That's it. So this way you can summarize the table. Right? So you can adjust the space. Yep.
So what does lower bound and upper bound indicate?
Yeah. So 1 minute, 1 minute. I'll come back to you. So any statistics, any study we conduct, the study is about the population, how the training is effective. But we not select the entire population. So we have taken 10 candidate sample. So how the sample is reliable with reference to the population. When you repeat the same studies again and again in the population, having 10 sample size for beginner, intermediate, and advanced, or when you conduct the study for 100 times, or when you conduct 1,000 times, when you conduct the study for 10,000 times or 100,000 times, 95% of the time, when you repeat the study, the beginner, the time duration will be from these two range. 26 to 29 minutes. 95% of the time you conduct the study, the mean of the beginner module will be from this range. Lowest to 26, highest can go to 29 minutes, 29.5 minutes. 5 times when you repeat the study, your mean can go higher or mean can go lower. 95, that is what the 95% confidence says. 95 times, 95% of the time, your results will be similar to this. Your mean will be from these two range. 5 times out of 100, 5% of the time, your results can go other way around. Higher than this upper boundary, lower than this lower boundary. Agree with me? Agree with me? This is about the confidence interval for the mean.
Thank you, sir.
Okay. Yeah. Simple way I have explained you. Easy to remember. So we have a confidence, 95% confidence based on the mean is that 95% of the time the study was repeated, the mean will be from these two range. 5% of the time, the mean will be away from the range. Meaning it is about your preciseness of your study based on the mean. Preciseness estimation. Okay. Suppose if you do not need this many decimals, you can reduce the decimals. 2 decimal, fantastic. Now, as a footnote, we need to write like this. Each value is the mean of 10 employees. Each value is the mean of 10 employees. And we need to spell out values having different superscript are statistically different. So we are going to assign the superscript. How we can assign the superscript? So we have mentioned that for the table, the last one. The last one, participant. This one, you copy this. So advanced and intermediate comes in one column. 23 minutes, 24 minutes are they are very, very closer. So we give them similar superscript. Meaning we give them A, and this is we give them B and B. Is that okay? Is that okay? So each value is the mean of 10 replicates, 10 respondents. This is what we need to write. So it says that intermediate and advanced are similar responses, similar time duration they have taken to complete the spreadsheet program. So the mean values between intermediate and advanced, statistically no difference. But beginner, they have taken more time to complete the program. Please tell me, have you all understood or not so far? Have you all understood so far?
Yes, that's clear. Thank you.
Okay, so this is the way we need to assign. This is the way we need to assign. Whatever the column comes in this particular column, first column, we give one symbol. This is another symbol. So I have given, this is for A. This two comes in one column. I have given B and B. So comparing intermediate and advanced, time duration, no difference. So we have assigned similar superscript. Shall we move on to the next exercise? We have remaining 1 hour. I have a lot of statistical tests to cover. Please go to one. We are going to go for non-parametric. Sorry, we can conduct a correlation and regression. Then we move on. Correlation and regression. Okay. So I will open a one simple file. Easy. 1 minute. Yeah, please open the file. Advertisement versus sales. 13A2. Correlation and regression. Participant, please open 13A2. Correlation and regression, advertisement versus sales. Have you all opened it? Have you all opened it? Advertisement in?
Yes, sir.
Yes, sir.
So when normally we can use correlation? What conditions we can use it? What application we can use it? Whenever you have a two numeric variable to study about the relationship. Advertisement sales, are they related? Number of hours students they study for exam and their GPA. Number of hours you do exercise and your body weight reduction. Age versus systolic blood pressure. Age versus height and weight, are they related? Income versus happiness. If there is a what you call numeric, we can relate. So to study a relationship between the two numeric variable, we go for a correlation. Study the relationship. So parametric, we call them Psn correlation. Usually the Psn correlation coefficient from -1 to +1. -1 to +1. When there is a correlation, R value or Psn correlation equal to 1 + 1, a perfect linear correlation, meaning X variable increases, Y variable is increasing. Advertisement amount budget increases, sales in a company is increasing. More the advertisement, more the sales. Positive relation. Suppose when you conduct a correlation, Psn correlation, when you get the negative R value, close to -1, meaning your X variable increases, Y variable decreases. So correlation is meant for to study the relationship. Is there any relationship between the two variables? And also will answer how strong the two variables are related. The strength and direction of the relationship, we will come to know conducting correlation. So participant, you are provided with advertisement amount and sales volume. Imagine that all in 1000 Imagine that all in 1000 or all in 10 lakhs. Imagine that some number, numeric, or in lakhs. This is in lakhs and this is in lakhs. 4.69 lakhs, 12.23 lakhs sales volume. So advertisement, budget, sales, the revenue otherwise. Is there any related? So advertisement and sales, the data were recruited, collected from 24 companies, similar companies. So we are going to see, is there any relationship between advertisement and sales? So there are two ways we can study this relationship, graphically as well as statistically. Graphically, we can go for scatter plot. Statistically, we can go for a Psn correlation, parametric. Assume that the values are normally distributed. We are going to go for Psn correlation. Shall we run? Have you all understood the purpose of correlation?
Yeah.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Go to graph. Go to graph. Chart builder. Go to graph, chart builder. You have this window, chart builder window. Click from the gallery, scatter plot. From the gallery, scatter plot. Pick up the first one, simple. Pick up the first scatter plot. Advertisement, we can keep it in the x-axis. Sales, we can keep it in the y-axis. Please tell me. Please tell me. Have you all done it?
Yes, sir.
Advertisement, you keep it in the x-axis. Sales, you keep it in the y-axis. Just click OK. Your scatter plot is ready now. So based on the graph, we can come to know that is there any linear fashion? Please tell me, is there a positive relationship? Is there a negative relationship? Based on the scatterness.
Positive.
There is a
Positive
positive.
relationship.
Is it 100% positive? Is it 100% positive? No. So maybe positive relationship, but we do not know based on this how strong they are related. We do not know how strong they are related, but we could see there is a relationship. Yes. But we are interested in how strong the two variables are related. We need to go for Psn correlation. Shall we go for Psn correlation? Shall we run? Go to analyze.
Yes, sir.
Go to analyze. Correlate. Next to mixed model, correlate. Bivariate. Bivariate. Click on it. Do you have this window? So simultaneously, you transfer both variable from left side to the right side. By default, Psn has been chosen. There are three types of correlation. Psn correlation is meant for parametric, numeric data, continuous data. Ratio scale or interval scale data, we can go for a Psn correlation. Suppose you have some kind of one variable is a numeric, another is ordinal. Otherwise, the data does not follow normal distribution. You can go for a Spearman. Or both the variables are ordinal. What do you mean by ordinal? Ranked data. Ordinal means ranked data. For example, I have asked two questions. What is your level of income? Low income, medium income, high income. Please tell me your income level and your happiness index. 1 to 5. Very dissatisfied to very satisfied. So income versus the happiness. Then you can go for a Kendall's. Both the variables are ordinal variable. Non-parametric, you can go for a Kendall's.
And
So
so what
here
is the difference between Kendall's and Spearman?
Spearman is meant for even numeric data, ma'am.
Okay.
Numeric data, the data, any one of the variable does not follow normal distribution, you can use Spearman. Kendall is meant for both the variables are ordinal. Compulsory ordinal means we need to go for Kendall's.
Both should be ordinal, then we should use Kendall. Right.
Kendall's.
Understood.
If both the variables are ordinal means go for Kendall's. For example, one variable is ordinal, one variable is numeric, go for Spearman. Other way, both the variables are numeric, variables does not follow normal distribution, normality, go for Spearman. So if the data is normally distributed, numeric data, interval ratio scale, please proceed with Psn correlation.
Right. Thank you.
Okay. So just
Sir,
one.
sir,
Yep.
in that case, if we are
Hmm.
using the Likert scale in any of the variables, so we have to go with Kendall.
Yes, Kendall, ma'am. If both the variables are,
Okay.
Likert scale, go with the
Like
Kendall.
it's coded in a 1, 2, 3 or 1 to 5, then we can go with Kendall.
Kendall, you are right.
All right.
Excellent.
Okay.
Excellent. Yeah.
Thank you.
Okay. So once you have transferred the two variable, click OK. You will get one simple table. I have already mentioned the Psn correlation usually from -1 to +1. The Psn correlation -1 to +1. Look at the Psn correlation value, the star value. What does it say? What does it say? What does it say? Is it a positive or negative?
It's a positive and a strong
High correlation. You can say that
Positive, highly
positive,
correlated.
significantly, there is a linear correlation. Saying that advertisement increases, sales volume steadily is increasing. P less than 0.001. You can also see at the footnote the comparison of p-values. So this is a p-value. The p-value is so negligible. So we have significant evidence to say that there is a strong relationship, a strong linear relationship, perfect linear relationship. So any terminology you can use it between advertisement and sales. So this is a Pearson correlation, R equal to 0.916. Now, suppose your friend has got similar company. You have done the study, you also can recommend, or you based on this data, we can also predict. Suppose if I spend this much money for advertisement, how much sales I can anticipate? If I spend this much money for next year, how much money the sales I can anticipate approximately? We can get the data. How do you do? What statistical test will be relevant? We are going to predict, we are going to anticipate. What test will be relevant? What statistical test will be relevant? Anyone?
Regression.
Yeah, fantastic.
Regression.
Based on this data, we can predict, we can anticipate for a given X. Suppose I'm going to spend for 4 lakhs rupees for advertisement. How much volume based on this research data I may generate? How much sales I may generate? For that, we can run for regression. Shall we run the regression?
Yes, sir.
Very fast. The time is limited. So there are two approaches you can run the regression. One graphical approach, another one statistical approach. So I will demonstrate both the way how you run the regression. Already we have generated the scatter plot. Already we have run the scatter plot. Just double click on the scatter plot. Just double click on the scatter plot. Please tell me, have you all opened it? In the chart editor, can you please see there is a add fit line at total? Can you please see add fit line at total?
Yes, now visible.
Just click on it. Just click on the add fit line at total. That's it. That's it. So graphically we have conducted the regression. Graphically we have conducted the regression. Please tell me now, what does it say? Regression equation equal to y equal to a plus bx. Y equal to a plus b. Y means the sales here. We are going to predict the sales from advertisement. Suppose if you spend for 4 lakhs rupees for advertisement, how much sales approximately you may get around this point? Say so, no participant. Around this, around 11 lakhs something we may get. If you spend for 4 lakhs rupees, approximately we may get. So using this equation, exactly we can predict. So then what do you mean?
Just repeating the chart editor, how did it came? Just missed it. Though yesterday also you told us.
Say again, ma'am, I didn't get you, ma'am.
I said, just will you quickly repeat from where did we got the chart editors window? I just missed that step.
Just to double click the graph, ma'am. The scatter plot.
Okay. Yeah.
Just double click the graph using your left mouse. You will get the elements chart editor window.
Oh, now got it.
From,
Thank you so
yeah,
much.
From,
Thank you.
from the third row, add fit line a total. You need to go
Right.
for it for adding the trend line.
Right.
Adding the
Got
trend
it.
line along with the equation.
Right. Got it. Thank you. Thank you.
Okay. So you have been provided with y equal to a plus bx, the equation, regression equation, along with r square value. What does it mean, the r square value?
The goodness of fit.
We can say that coefficient of determination, not goodness of fit, ma'am.
Sorry, sir, sorry.
Coefficient of determination. What does it say? 83% of the variance you see in the sales can be attributed by the advertisement. Meaning, do you think sales only influenced by advertisement?
No, sir.
There are several factors. Where the study was conducted, what kind of product, what kind of people are there. So there are several factors may influence. So based on this hypothetical data, advertisement explains only the 83%. The remaining 17% may be some other factors. As a researcher, we do not know, maybe unknown. So advertisement explains the sales only 83%. Understood the concept?
Yes, sir.
83% of the sales can be explained by advertisement. The remaining 17% we do not know, maybe some other factors, which is very good. 83% is very good, right? So advertisement significantly predicting the sales. 83% means very good. So 100 people having the spending for advertisement, 83% of the people having advertisement, the sales is increasing. Fantastic. Right? So shall we run the regression by statistically?
Yes, sir.
Please go to the regression is nothing, R square is nothing but 0.916 multiplied with 0.916. Please tell me how much. R square value is nothing but your R value square it. A Psn correlation, just square it. 0.916 multiplied with 0.916. How much you get? This is called R value. The regression coefficient or coefficient of determination. Participants, have you all understood? Understood or not?
Yes, sir.
Okay.
Yes, yes.
So
Yeah.
please go to analyze. I'm going to demonstrate how to run the regression. A regression. The second one linear. Second one linear. Click on it. So please remember, what variable is a dependent variable?
Sales.
Sales.
Sales depending on advertisement. Sales is depending on advertisement. So sales you have to transfer into the dependent. We are going to anticipate, we are going to predict the sales. Right? We are going to predict. So the variable you are going to predict, we need to consider as a dependent variable. We have to place them in the dependent. Advertisement influences dependent. Advertisement influences sales. So advertisement is independent variable. Please remember. So the variable you're going to predict should be on the y-axis. The variable influencing the other variable should be in the x-axis. Understood?
Yes.
Understood? While conducting the scatter plot also, we have to be very, very careful. So conducting correlation, y will be in the dependent variable in the y-axis. Dependent variable should be on the y-axis. Please remember. Conducting correlation, you can put it anywhere, but same correlation you will get. Sales can be in x-axis, advertisement can be in y-axis for scatter plot. For prediction regression, that's when you go for prediction, the dependent variable should be on the y-axis. Remember, we never ever should do the mistake. Okay, so that's it, participant. Just click OK. Just click OK. You will get one simple tables. With that, we can interpret. Please tell me, have you all got the output?
Yes.
Yes.
Yes,
So,
sir. Yes, sir.
So this is R value, Psn correlation. When you multiply this value, 0.916 multiply with 0.916, this is R square value. The same thing we got it in the graph. 0.839, 83% of the variance in sales can be explained by advertisement. So advertisement influences sales by 83%. Agreed? Whether this model is a significant or not. Whether this relationship, whether advertisement predicting the sales, is it significant or not? Look at the Anova table. So Anova table says that advertisement significantly predicting the sales. So the model is very good. The model can be used for prediction. The model can be used for prediction and also estimating and creating the equation y equal to a plus bx. Now look at your coefficient. Look at your coefficient, meaning this is a constant. What do you mean by constant? Anyone, could you please tell me? What do you mean
So
by constant?
amount of sales when the advertisement expenditure is 0.
Fantastic. If you don't do any advertisement, the minimum sales will be like this. If you don't do advertisement, without advertisement, but the sales will be base level will be this. From this, every 1 unit increases. This is low value advertisement spending. This is a B. This is A and this is B. Constant actually is an intercept. We used to call them. Intercept means when you, this is a intercept where exactly the trend line connects. The trend line connects at around what you call this value, 6.583. The trend line, it connects in the y-axis at 6.583. Is that okay? Understood? This
Yes,
we
sir.
call them as an intercept. This we call them as a what you call constant. Constant 0. When advertisement is 0, this much will be the sales will be there. Okay. So then what does it mean? The second one, this we call them as a slope. What do you mean by slope? Every 1 lakh rupee increases in your advertisement, this much unit of sales volume will increase. Agree? Agree? So just copy this.
Yes.
Yes, sir.
Just copy this coefficient table. Go to Excel. I will demonstrate very fast.
That is the slope.
That's the slope. Look at here. Paste your regression, the coefficient table. This we call them as an intercept. Otherwise, we can call them as a. This is actually is a B. We can call them as a slope. So equation is y equal to a plus bx. So y means sales. Y means sales. So shall we substitute this? For example, you are interested in spending for 4 lakhs rupees. You are interested in spending for 4 lakhs rupees for advertisement. How much? Based on this constant and advertisement, sorry, constant and slope, how much sales volume you can anticipate? Shall we?
Yes, sir.
Say here, put equal to
584.
6.584 plus
1.0.
1.071
071.
multiply with
4L.
4. This is what it says. 10 lakhs something, the sales volume will be there for if you are interested in spending for 4 lakhs. Suppose you have 5 lakhs, you have decided how much will be. You are decided to spend for advertisement for 5 lakhs. How much based on this we can anticipate? Just copy this and paste it here. Instead of 4, you modify 5. So how much difference between these two? One candidate, he spent for 4 lakhs for advertisement, he got it this much. Another candidate, he spent for 5 lakhs, he got it this much sales. How much difference between these two people? How much difference? You will get the slope value. This value, sorry. Please tell me, have you all got it? Put equal to this value minus this value. You will exactly get the slope value. So it says that every 1 unit in your x-axis or your advertisement increases, the slope value will increase in your y-axis. That much times. Understood or not?
Yes, sir.
I hope you would have understood the correlation
sir.
regression.
Yes, sir.
Okay. So the next one is we have a couple of non-parametric, 3 or 4 non-parametric. We have another 30 minutes to go. Let me try. Please open the file. 15A3. 15A3. Chi-square cross tabulation, gender versus preferred learning medium. Chi-square cross tabulation, gender versus. Also open the study major. Sorry, you can open the study major, please. 15A3 chi-square analysis, gender versus study major. Open this file. 15A3 chi-square analysis, gender versus study major. Have you all opened it? Participant, have you all opened it?
Yes, sir.
Okay. So when we can use chi-square analysis? When we can use chi-square analysis? Suppose you have a nominal versus ordinal or nominal versus nominal, meaning gender is a nominal variable, qualitative variable. Major is a subject major is a nominal variable. So whenever you have nominal variable with the nominal variable, is there any association? We can go for chi-square test of association. Understood? Qualitative variable, categorical variable. Is there any association between gender versus the preferred major? I will explain you the scenario so that you will have some clarity on this. So one researcher is interested in study about the association between gender versus the preferred the subject for undergraduate program. Or male, do they prefer a particular subject, or female prefer a particular subject? Agree or not? Is there any kind of, or is there any association between gender, any particular gender, do they prefer any specific degree program? Do you think any kind of association will be there nowadays? Do you think any association will be there? Yes or no? So this kind of data, we can go for chi-square association, chi-square test of association. Both are categorical. Gender also, you asked only 2 questions. Some of the students have completed 12th standard in India. +2. You asked 2 questions. What is your gender? Which program you are interested in studying? You have collected the data. You are going to see, is there any association between gender and a particular major, a course they are interested in studying? Is there any association? Agree or not? Both are qualitative, both are categorical, both are nominal scale. So nominal versus nominal, we can do association. Is there any association between gender versus the preferred major?
So can it be possible nominal versus ordinal?
Also possible, ma'am.
Nominal versus ordinal?
Nominal versus ordinal also you can go for chi-square. Otherwise, I will give you one more example. Gender versus the happiness. Very satisfied to very dissatisfied. So male and female, is there any kind of association? More male are very satisfied or more female are very satisfied? Agree? Or kind of some agreement. Male and female regarding the agreement about the taxation in the country is very high. Taxation in the, I have given 2 questions. What is your gender? Taxation in the country is very high. What is your? Is there any association? So this kind of scenario, we can go for a chi-square analysis. Otherwise, you can go for another simple question. Are you working in a private sector? Are you working in a government sector? Please rate taxation in the country is very high. Strongly agree or strongly agree to strongly disagree. Taxation in the country is very high. What is your agreement? Whether you are working in a private sector or working in a government sector. Is there any association? People working in a government sector, do they feel more tax burden? Or people working in a private sector, do they feel more tax burden? Is there any such association? We can go for chi-square test of association. Please tell me, have you all understood?
Sir, in that case, you are saying, if I can understand, we can, in case of Likert scale on any of the variable, if we are using, we can find out, chi-square among
demographic
employees.
variable versus, yes, you can go for it now. Yeah. Yeah, right.
Maybe let me take your word. Demographic variables or the people who are working in private sector have more job satisfaction or people working in. So that way we can do. I mean, if
yes, you're right. You're right. Absolutely right. Absolutely right. We can go for association. Is there any association? Nominal means.
Can we do two chi-square between the two ordinal scales also? Maybe job satisfaction and commitment.
Yeah, possible.
We can
possible,
do
ma'am.
that.
If both are Likert scale, can be.
Okay.
Can
So,
be. You can.
Any two Likert scales can be used for.
Yes.
We can
yes.
use.
Yes. Nominal versus nominal can be used.
Okay.
Okay. So you also can go for, ma'am, relationships. Spearman also can run. Kendall's also can be done. Those kind of data. Ordinal means you can go relationship.
So that is a correlation. But if I'm talking
both are,
about the
no, if you are both are ordinal means you got to go for
correlation.
Both are ordinal means you got to go for what you call correlation.
Okay, so in
for example,
one has to be nominal.
One, if it is nominal, you can go for it. One nominal, one ordinal can be conducted.
Okay. Thank you, sir. Thank you.
Okay, so please go to analyze. Please ignore the last the 7 items not required. I'm going to delete it. The last 7 items is not needed. It's all not needed for the analysis. Just you delete. So we are interested in. We asked 2 questions among the students whether do they like it. Otherwise, I'll give one more example. You asked 2 questions among your students. Do you like cat as a pet animal? Do you like dog as a pet animal? What is your gender? What is your opinion on this? Whether male students, do they like dog, or female students more they like dog? Is there any such association? Is there any such association? Nominal versus nominal, cross tabulation. We can go for chi-square. I hope you would have agreed. Okay. Shall we run? Go to analyze.
Yes, sir.
Descriptive.
nonsense
Go to analyze descriptive. Can you please see the cross tabulation? I'll repeat again. Analyze. Descriptive statistics, cross tabulation. So right click and see display variable name, gender in the column, major in the row. Just to transfer it, display cluster bar chart, click statistics, click statistics, chi-square. Click statistics, chi-square. Continue, that's it. Continue, that's it. Click OK. Click OK. I hope you would have got the results.
Yes.
Yes, sir.
Okay, give me 2 seconds. My system is very, very slow today. Okay. Look at here. There are 183 candidates. The data were collected. No missing. 183 candidates were collected, including male and female. And their preferred subject, the preferred major were asked. Please tell me which subject there were more candidates. 54 student psychology, female student psychology. Only male, less male, they prefer psychology. Look at here, economics, 7 female, 28 male prefer economics. 12 female, they prefer sociology. 21 male, they prefer sociology, more male compared to. Anthropology, 15, 22, others 4 and 12. So the numbers, the frequencies, male and female, are they equal or are they different? Or is there any association or any particular gender? Do they prefer any specific major course? Or is there any preference among the male and female? Please tell me. Is there any association between these two? So null hypothesis we stated there is no association between gender versus the preferred major subject. Participant, please put your audio in a mute mode. Please. We are in a common forum. Time is very short. Please. Participant. So please tell me. We have to look at the chi-square value. We also need to look at the p-value. So when your p-value less than 0.05, we have a valid evidence to reject the null hypothesis. Null hypothesis we have stated there is no association between gender versus the preferred major subject. But the results we got it says that there is a significant association. There is a preference among the gender. Meaning more female they prefer a particular subject. More male, less male they prefer a particular subject. So there is a variation, there is a differences in the preference among the gender. Please tell me, have you agree with me?
Yes.
Is that the interpretation is justifying? Okay. So I have given you a couple of examples. Please carry on with. I have given you a couple of examples. Please carry on with. You can practice. Please go to the next one is 17A3. 17A3 Man Whitney. 17A3 Man Whitney. Open it. Customer satisfaction. 17A3 Man Whitney test customer satisfaction level, private bank and public bank. Private bank and public bank. So when we can use this Man Whitney Wilcoxon rank sum test? Please remember this particular Man Whitney Wilcoxon rank is equivalent to independent sample t-test. Equivalent to. When it is a parametric, we go for independent sample t-test. Equivalently, non-parametric, we go for a Man Whitney Wilcoxon.
Can you
So
please
outcome
repeat
variant.
what you said? When can we use?
Ma'am, this is just equivalent to non-parametric. Sorry, this is equivalent to independent sample t-test. Man Whitney Wilcoxon.
Okay.
The purpose is
Any assumption or any limitation or any conditions for sample size?
Sample size not
Independent
much, ma'am.
sample t-test and this one?
The same condition, ma'am. Same conditions applicable.
Okay. Right.
Okay. So comparing two group of people. Comparing two group. People are having account in public bank. People are having account in private bank. And their satisfaction. The satisfactions are rated ordinal. The satisfactions are ordinal. Ranking. Moderately satisfied, neither dissatisfied. There are several categories. Look at here, variable view. Very dissatisfied to satisfied. There are 5 categories were given. 5 kind of categories. Ordinal. So we are going to compare among the customer whether a private bank provide more customer satisfaction or public bank do they give more customer satisfaction. How about your opinion on this in Indian context? Which bank the customer satisfaction will be very good? Private sector or government sector?
Private.
Mostly private sector. So this is a one hypothetical data. A study was conducted. One PhD student comparing the satisfaction level between 2 different types of banks. Apple versus orange again. Public bank, private bank. Outcome variable is a ranking, ordinal. Shall we run? Shall we run? Go to analyze.
Yes.
Go to analyze. Can you please see there is a non-parametric below the scale? Non-parametric. Can you please see there is a leak acid dialog? Leak acid dialog. Actually, SPSS actually is a very vast lot of statistical applications. So within 6 hours to cover parametric and non-parametric, very tedious. But somehow you all very good. Statistically, you have most of them. You understood the concept. That is what I could be able to complete this much, at least this level. Beginner, frankly speaking, coming for this level is very difficult. Boring. Otherwise, you will miss something. We cannot go this much speed. Right? Even then, I didn't explain much theory. I have taught you only the applications. Somehow you picked up. You understood the concept, understood the interpretation also. Appreciated all the participants. Okay. So analyze non-parametric leak acid dialog. You have to select 2 independent samples. Why 2 independent? Participants are different. For example, some candidate having account in private and public, the candidate is not eligible to give the opinion. So entirely different independent candidate, the opinions were asked. The satisfaction record were compiled or collected. So click on independent samples. You all have this window. You all have this window.
Yes, sir.
So please
Yes,
transfer your bank into the grouping. Please transfer your bank into the grouping. Satisfaction score into the test variable. Satisfaction score into the test variable. So now we have to spell out private bank how you coded, public bank how you coded. We need to know 1 and 2 we coded. 1 means private bank, 2 means public bank. The coding we need to spell out here. Click on bank so that the grouping variable activated. The define group is activated. Click define groups. Group 1 coded with 1, group 2 coded with 2. Group 1 coded with 1, group 2 coded with 2. Understood? Understood, participant?
Yes.
Yes, sir.
Yes, sir.
So now continue. Then by default, Man-Whitney has been chosen. By default, Man-Whitney chosen. Just proceed. Very simple. Just proceed. Just click OK. Just click OK. So the previous example, we did not interpret the graph. Can you maybe, I will spell out also. See here, this is a distribution of the, what you call male and female in the different subjects. So the height of the bar, some subject is more, some subject is very less. There is an association between male and female. Okay, yeah. Look at here, the Man-Whitney, you test the result. Look at here. There are 79 customers from private bank. The data were collected. 71 customers from public bank. The data were collected. You may see the difference now. Previously, we have discussed parametric mean value. So here you see here, it's a mean rank. Mean rank. Meaning, based on the value, we arrange the ranking and then segregate the rank of private bank and public bank. Then average rank were calculated. So this is a sum of ranks of private bank. This is a sum of ranks of public bank. So 6650 divided by 79, you'll get this 84.18. 4674 divided by 71 candidate, you'll get 65.84. Agree? So 150 candidate, the study was conducted. Now, higher the rank, higher the satisfaction. Higher the rank, higher the mean rank, that is a satisfaction. Now, can you please tell me, based on the mean rank, which bank the satisfaction is good?
Private banks.
Private banks is
Private.
good. Yes, yeah. So is it significant? Is it statistically significant? You have to go to the test statistics. You have to go to the test statistics. So this is a Man-Whitney U value. When you use a formula for calculating the Man-Whitney, this is the statistics you get. Man-Whitney U statistics or Wilcoxon statistics. And this is actually the p-value. When your p-value less than 0.05, you have valid evidence to reject your null hypothesis. So we reject the null hypothesis saying that the customer satisfaction between private bank and public bank are equal. But the results show that there is a differences. Private bank do provide more customer satisfaction when compared to public bank. P less than 0.05. Understood or not?
Yes, sir.
Understood?
Yes, sir.
Okay, fantastic.
So can
Fantastic.
you tell again the Man-Whitney's interpretation?
Yes, ma'am. So a study was conducted. Man-Whitney U test was analyzed using SPSS for comparing the mean rank of customer satisfaction between private bank and public bank. And the mean rank of private bank was found to be 84.18. The mean rank of the customer satisfaction of public bank was found to be 65.84, comma, the Mann-Whitney U-test this value, comma, Z value equal to this, P less than 0.05. The results reveal that private bank customer do have more customer satisfaction significantly. P less than 0.05. That's it, man. This is the way you need to go for writing your interpretation in 1 or 2 sentences in your research paper. But the table can be given in your result section. 1 or 2 sentences simply we need to write based on your own language. You don't need to refer any textbook, any journal, any research paper. Based on your simple language, you can elaborate your results, interpretation. You no need to, you can go check for what you call participant. Please put your audio. Please put your audio in a mute mode. Please. Please check your audio.
Sir, not meeting the normality condition is the only we are using this Mann-Whitney.
Say again, ma'am.
Like you said in the beginning that this test is equivalent to independent sample t-test.
Yes, ma'am. But Mann-Whitney comes under non-parametric, ma'am.
Yeah, because if normality condition is not met, only then we can go for Mann-Whitney.
You are right. You are right.
Okay,
you are right.
Okay.
Suppose.
Otherwise, the other things are similar between the two.
Yes, ma'am. Otherwise, your outcome variable is an ordinal variable. You cannot run the parametric. If it is numeric, the value are normal distributed, you proceed with parametric. Your outcome variables are numeric, the data does not follow normal distribution, you go for a Mann-Whitney. Otherwise, your outcome variable is ordinal. You don't need to test that what you call normality. Straight away, you can go for a non-parametric. Agree? So this particular data is ordinal. Outcome variable is ordinal. Ranked data. That's what we have chosen Mann-Whitney.
Okay.
Okay. Yeah. So please go to the Wilcoxon signed rank test 18A1. 18A1 Wilcoxon signed rank test. So this particular test similar to paired t-test. This particular test similar to paired t-test. Pre and post, before and after, before training, after training, before treatment, after treatment. Imagine that people normally will go for acupuncture treatment for pain reduction. So one company providing acupuncture treatment for back pain. So a researcher wanted to know whether the acupuncture particular treatment is it effective or not. So they recruited 25 candidates who are having back pain problem. So before going for the treatment, they were asked, please rate your pain score from 1 to 9. 1 to 10. Before going for the treatment, please rate your subject. This is actually subjective rating 1 to 10. 10 means high pain, 1 means very less pain, 0 means no. So this is what the before training, same candidate, before treatment, the pain rating. This is after treatment, the pain rating. The research question is there any difference between pre and post? Is there any effectiveness of acupuncture treatment? This is a ranked data. Assume that the values are not normally distributed. We cannot go for paired t-test. We are going to go for non-parametric Wilcoxon signed rank test. Understood the purpose? Understood the application of Wilcoxon signed rank test? Participants have well understood?
Yes, sir.
Okay.
Yes, sir.
Yes.
So in
Please
case
go.
the data is ranked and the normality is not met, these are the two conditions. Okay.
Yes, ma'am. Yes, ma'am. You're right. Go to analyze. Non-parametric Likasi dialog. This time what we need to select? From the sub menu, what we need to select? Please tell me. The variables are related. Same subject we are measuring in 2 time points. Yes or no? So we have to select 2 related. 2 related. Agree?
Yes, sir.
Just click on it. Just click on it. So what we need to do? You select both together. Click this arrow. pain score, pre and post. By default, Wilcoxon has been chosen. By default, Wilcoxon has been chosen. Just click OK. You don't need to do any modifications. You need to remember where a Wilcoxon signed rank test is located, how to key in the data, transfer the variable, click OK. SPSS output, you will get the output, what you call the results. Click OK. Now tell me, have you all got the output?
Yes.
So what does it say, the first table?
Yes, sir. Yes.
What does it say, the first table? There are 7 candidates. After the treatment, the pain has been reduced. After the treatment, after 4 weeks, the pain has been reduced. 14 candidates, the pain has been increased. 4 candidates, before and after, no difference. There are 25 candidates were responded. Before and after were equal. Have you agree with me? Have you all agree with me? So there are 7 candidates, pain reduced. 14 candidates, the pain is increased. 4 candidates, before and after, no difference. So with that, can we conclude the acupuncture is effective? Do we have valid evidence? Statistical evidence. Look at here, the sum of ranks of negative 78.50 divided by 7 candidates, you will get 11.21. 78.50 divided by the number of negative ranks, you will get mean rank 11.21. The sum of rank of positive candidate 152.50 divided by the 14 candidate, you will get the mean rank of 10.89. Now the negative mean rank, positive mean rank, they are very, very close, right? 11.21, 10.89. Very, the mean rank somehow closer. Can we say that acupuncture is effective with that results significantly?
No,
there is a slight difference
no,
is there. There is a slight difference is there.
Yeah. Though there is a slight difference, but yeah. But from the significant value, so we cannot reject the null hypothesis.
Fantastic. So p-value is greater than 0.05. It says that we do not have evidence to reject the null hypothesis. Statistically, the acupuncture treatment is not effective. Pre and post, there is no such significant improvement. There is no such improvement. So the particular training is not so effective. Please remember, this is a hypothetical data. I'm not against acupuncture. Okay, please take note. This is a hypothetical data. So I have taken it.
Right, sir.
So I'm not against that.
Yes, sir. Yes, sir.
So maybe acupuncture may be effective. So this is again a hypothetical, simple example to teaching purpose. I have chosen this data. So don't take it other way. Acupuncture may be effective. I'm not. Okay. Understood? Understood?
Sir, excuse me, sir.
Yeah.
Excuse me, sir. Sir, these are all data from different samples. So the same thing if collected from another samples, the result may vary also, sir.
Vary, sir. Accordingly, you have to interpret.
Yes, sir.
That's what, sir. The same study you conduct, you may get one different result. I may get different results.
Yeah. So it will be like a case study only, sir.
Yeah, you're right.
Yes.
Okay. So we have conducted the Wilcoxon signed rank test. The last one is Kruskal-Wallis. The last one is Kruskal-Wallis. Please go to the Kruskal-Wallis. 20A1. Again, back pain, 3 group of people. 20A1.
20A1.
Kruskal-Wallis test example, back pain rating 3 groups. Drug A, B, and C. So one researcher, maybe pharmaceutical related researcher, wanted to test. He has 3 different types of drugs. Maybe we have 3 different branded paracetamol. We have 3 different branded paracetamol reducing the body pain. Which drug is effective? Which paracetamol brand is effective? The pain rating is a ranked data. The pain rating is a ranked data. Ordinal data. So the data does not follow normal distribution. We cannot run one-way analysis of variance. Equivalent to ANOVA, non-parametric, we have Kruskal-Wallis. So comparing more than two independent groups. So how do you state this null and alternate hypothesis? How do you state null and alternate hypothesis? Anyone help me out?
Yes, sir.
Please.
So there is no significant difference among different drugs.
Okay. In terms of pain, there is no difference in
And the
pain
pain
rating
score.
among the pain score among the drugs. There is no difference. Whereas in the alternate hypothesis, the research hypothesis, we say that there is a difference in pain score among the three. So we are going to test the hypothesis. Shall we run?
Right, sir.
Okay. Go to analyze.
Yes, sir.
Non-parametric. Click acid dialog.
K independent.
This time we have to need to go for
K independent sample.
K independent.
K independent.
So Mann-Whitney, Wilcoxon, we need to go for 2 independent. K independent means more than 2. K means more than 2 independent samples, more than 2 independent drugs. We have it. So 3 drugs we have. So we are going to compare drug A versus B versus C. K independent. All right. So tell me now, pain score should go into the test variable. Drug treatment should go into the grouping variable. Please remember, drug A were coded with 1. Drug A coded with 1. Drug B coded with the 2. Drug C coded with the 3. So we need
so
to
this time 1, 2, 3.
Yeah, 1, 2, 3.
Minimum 1, maximum 3.
Yeah. So in the grouping variable, define range. Minimum is 1. In the value label, maximum is 3. That's what we coded. Suppose you have coded minimum 2, maximum 4. That number we need to spell out. Or 0, 1 and 2 if you have coded. The coding you need to remember. So what coding you have adapted for labeling your independent variable, that value we need to keep it here. Agree, sir? Agree? So minimum is 1, maximum is 3. Continue. Kruskal-Wallis has been chosen by default. Just click OK. Just click OK. That's it. So there are 20 candidates. There are 60 respondents participated in the study. 20 candidates were placed in drug A, 20 were placed in drug B, 20 were placed in drug C. So lower the pain rating, the particular drug is effective. Please tell me which drug is so effective. Is there any difference?
C.
Looks like drug C is a lower rank. Meaning drug C can be more effective when compared to drug A and B. Looks like. But is it significantly different?
Yeah.
We need to refer the last row. Look at the p-value, sir.
Yes,
Is it less than 0.05, right?
Right, sir.
The lesser than the 0.05%. This is 2.8%. So significantly, drug C is more effective than drug A and drug B. Agree?
Yeah, sir. Yes, sir. Yeah. Means, sir, there is significant difference among the different drugs. And while writing, we can write from the mean rank, we can write that drug C is more effective than
yes,
the other two drugs.
You are right. This is what the inference is. This is what we need to write the inference.
The lowest the pain score, the more it is the effective.
Fantastic. Fantastic. So for example, the pain rating we asked, 1 means lower pain, 10 means higher pain. So the mean rank when it is lower, the drug is effective. Agree? Agree?
Yes, sir.
Okay.
Yes,
so one more way also I will demonstrate.
So the hypothesis.
Say again, ma'am. One more way also I will demonstrate how to conduct the Kruskal-Wallis. Please go to the table. Please go to the Kruskal-Wallis example. Go to analyze. Go to analyze. non-parametric independent samples. Could you please select independent samples? The inference also system will give you. Independent sample. Click on independent sample.
Yeah. Yes, sir.
1 minute. Do you have this window? We are going to compare.
Yes, sir.
In that we are going to compare the medians. Click on this. Compare the medians. Sorry, the first one also okay. Automatically compare the distribution. The first one is fine. First one is fine. Click on field. Click on field. Can you please transfer your drug into the group?
Yes.
Paint score
paint
into
score
the test
to
field. Test field. Agree? And then click settings. Click settings. Can you please see there is a customize settings. Settings and customize test. Settings and customize the test. Crystal Wallis. We can also here the previously we cannot do the multiple comparison. This particular option you can do multiple comparison. Participant, have you all understood?
Yes.
Have you all done this? Have you all done
Yes.
this?
Yes.
Once you have done this, click run. Click run. That's it. This is another way to conduct non-parametric. Crystal Wallis also can be. Man-Whitney also can be conducted. Wilcoxon sign rank test also can be conducted. One minute, it is taking little time.
Yes, sir. So here it is written in the decision reject the null hypothesis.
Yeah, that's what you will get the output also. 1 minute, it is taking little time. The last one also pending. I will explain you the reliability. Cronbach's alpha. Some of you may run the survey related research, right? Participant. You may also run the survey related research, right? 1 minute. I will teach you. So this is what the effect. This is what the output. Double click on the graph. Sorry, double click on the table. The model viewer. Do you have this window? Do you have this window? You could see the graph also.
Yes.
So the drug C is lower than the other two. Reject the null hypothesis at alpha 0.05, a 5% order significance. The same results, p-value less than 0.05. Then we also can compare drug A and drug B. How we can? You can change it here. Firewise comparison. You can click on it. Now you see here, this is drug A, this is drug B, and this is drug C. Look at here, drug C versus drug A. Look at the p-value. So drug C is better than the drug A. Drug C versus drug B. The p-value less than 0.05, meaning drug C is better than the drug B. Look at the drug A and drug B. The p-value, what does it say? Greater than 0.05, meaning drug A and drug B, it shows the similar results. Drug A and drug B shows the similar results. But we can conclude that drug C is better than drug A and drug B. So think about it, where this will be relevant. I hope you would have understood. So whatever the statistical test I have covered. So please go to the last exercise. Last exercise. The reliability. Could you please open the file? Data. 1 minute. Job satisfaction anywhere written as the 1 minute. Yeah. 3A. 3A job description data frequency analysis. Could you please open? So when you design
what's
a
the
survey,
number?
3.0A.
3.0A. Yeah.
3.0A job description data. So whenever you design a survey related research, you frame a questionnaire, how consistent the responses are. You develop some questionnaire with some items. For each construct or each factor, we go with some items. So how the respondents answered for a particular construct or a particular factor, a dimension for the given items. So to do that consistency, we go for a Cronbach's alpha. Usually anything 0.7 and above the Cronbach's alpha, your item is very good. Your questionnaire you have drafted, your questionnaire is very good. You can proceed with. If there is anything less than 0.7, you need to modify the questionnaire, meaning where respondents may not understood the question properly. So the answers are not in a uniform fashion. That is other way around. So usually Cronbach's alpha are conducted for survey related research to assess the internal consistency. How consistent your items among the respondents, among the customer, among the students, among the participants. So here you have been provided with many items. What are they? Employment performance, attitude towards the co-workers, occupational commitments, organizational commitment, job satisfaction, staying intention. Environmental perception, attitude towards the co-workers, organizational commitment, job satisfaction, stay intention. So there are
Sir,
5 dimensions.
Sir, I have a question.
Yeah.
This is a data what you are saying when we construct our own questionnaire.
Okay.
But
Any
if we are any questionnaire or I mean if we are taking the standard questionnaire, standard scale in that case.
Also, ma'am, you have to present your what you call Cronbach's alpha.
We
your
can
methodology.
We can spell run out. That. Okay.
You also need to run. The study was conducted in the US.
Okay.
The authors are from US. The participants are from US. Okay. The same instrument you have used in Indian context. Indian context. The question were in there also in English. In India also conducted in English or different language.
Okay. So
you have to spell out the questionnaire. You have to spell out the questionnaire I have adapted from so and so author.
Okay.
Administered for this many respondents in India in the particular state. The language also followed English as well as in another language. Okay. The Cronbach's alpha was conducted. This is what the Cronbach's alpha was found to be. Okay. You have to spell out.
Okay. Fine.
Okay. Okay. So the contexts are different, ma'am. Different place the study was conducted. Even then you use.
And sir, this is done on the pilot study?
Both, ma'am. Both need to.
So, sir,
both you have to spread.
In that case, if we are talking in context of, for example, as you said, I take the test from US and I'm wanted to conduct on Indian population, specifically in Delhi. So I need to mention that, and the industry also in that case, maybe if during the pilot study, during the initial screening.
You have to transparent, whatever you do, methodology, you have to be transparent.
Okay. And in case if I find that any of the question is not consistent, as you said, below 0.7, so you
have the option, you can modify it in your
Okay.
pilot study, or you can rephrase it, or you can remove the question.
But can we do it on the standard scale, which is given by the author? We need to take the permission or okay.
No, not compulsory, ma'am. Anyhow, you are going to reveal your answer.
Okay.
You have conducted in India, the particular question, the particular construct, the Cronbach's alpha lower than that, one item was removed. That's it. Well and good. Well, and nothing wrong in that.
Okay. All right. Okay. Thank
so
you.
Whatever it is, you have to be very, very transparent. That is it. That's it. Okay. So there are 5 dimensions. There are 5 dimensions. Shall we run the Cronbach's alpha? EP, there are 4 items. Attitude towards the co-workers, there are 4 items. Organizational commitment, 4. Job satisfaction, 4 items. Staying intention, 4 items. So normally the researchers conduct each dimension or each factor, Cronbach's alpha, separately. Together also, overall also they may conduct. All the 24 items also need to be conducted. Shall we run? Go to analyze, scale, reliability. So I'm going to transfer only the EP first. Click on statistics, item, scale item deleted. Even Cronbach's this reliability analysis also SPSS will advise you. If you remove a particular question, whether do you meet the Cronbach's alpha above 0.7, will also give you the option. That's it. Continue. Then click OK. You will get the Cronbach's alpha for the first dimension, first factor. Please tell me how much the Cronbach's alpha you got it.
0.70.
Second.
0.885.
0.885. So which is greater than? Which is greater than 0.7. Well and good.
0.7.
Okay. Go to the another one. Go to analyze reliability. This time you transfer AC. Click OK. 891. 891. Reliability. Go to other one. AC, you remove. OC this time. Click OK. How much this is? 854. Well and good. 0.854, ma'am. 854. Scale reliability. This time you remove the JS. Click OK. 0.801 greater than 0.7. Go to scale reliability. This time staying in tension. Click OK. How much it is? 0.886. Is that right? There are 4 items. Shall we run finally for all the items together? All the items. Using your mouse, select all of them and the downward arrow until the staying in tension. Click OK. How much it is? 0.872. 0.872. So we have to capture all the reliability value. EP this much you have to capture. So you can copy this table. 1 reliability, 3rd, 4th one, 5th one, 6th one. Control C. Go to Word file. Sorry, Excel. Participant, please open an Excel file and just paste it. You can paste it here. It is taking time. Can you all see my screen? Is that visible? Excel giving problem. So we have to capture all of them and organize it to one simple table, the reliability analysis. So I need to restart. Okay. Just to paste all the table here, which we copied. Participant, have you all done it? So this is for first one is EP. You delete all this. This is for AC. Second one, what is this? OP, right? This is OP, organizational performance. This is for JS. One more is missing. Staying intention, did not copy, it seems. Did not copy. One we did not copy. 1, 2, 3. 1, 2, 3, 4. One is missing.
Sir,
Yeah, please tell me, ma'am.
sir, in case we do a factor analysis, there also we get the convex alpha.
Yes, ma'am.
Because
Yes.
when we are doing a factor analysis, there also
Yeah, we need to spell out.
convex alpha.
Yeah, ma'am, you have to do. So you need to summarize your output like this. So we need to write individual dimension were conducted for Cronbach's alpha, the reliability. It was found that the Cronbach's alpha greater than 0.7. It shows that internal consistency, that instrument is reliable to conduct a study. Is it okay? So this is a dimension or factor, or we can also go for construct. So simple table, just you need to summarize it. Is that okay? So
Excuse me, sir.
Yep.
One of the variables result come 0.7. Can we
0.7,
drop
okay,
that
sir.
variable or not?
0.7 means okay, sir. Anything lower than that, you can reduce. Think
Okay,
about it. Think about it. You can also justify. You can also justify.
Okay, sir. Thank you.
Okay, right, sir. Thank you very much, participant. I hope you would have gained something compared to the day 1 to day 2, day 3. I hope something, the knowledge I have given you. Hope the session was useful to you. So I thank all the participants. I had a good interaction also.
Thank you, sir. Thank you.
Thank you, sir.
Thank you,
Thank you, sir. It was good.
Thank you. Thank you very much, sir.
Thank you. Thank you very much, sir.
Thank you. Thank you.
Thank you, sir.
Yep, please, sir.
Sir, can we have a session on multiple regression analysis, sir?
Yes, definitely we are. But
I think somebody may conduct, sir. Somebody may conduct, right?
Yes.
We did a
Yes.
Okay.
multivariate
So you
regression
go-
analysis in case.
Yeah, I think
all the participants go.
So I have been given only for
Kindly.
3 days, ma'am. Maybe somebody else may conduct
Okay.
it.
Okay.
I wish you all the very best.
So all the participants kindly go through our content. So in that content, we have mentions what kind of things we are conducting in our workshop, right?
Okay.
All the participants.
Thank you, sir. Thank you.
Okay.
Yes, sir. I
Thank
think
you.
Das sir will be taking that part.
Yeah.
Yes,
Thank you, everyone.
yes,
sir.
absolutely.
Yeah. Yes.
So
Thank
all
you
of
very
thank
much,
you.
Professor Marimathu.
Thank
On
you so
behalf
much,
of
sir.
ASB University and participants, I convey my gratitude, sir, for being with us for 3 sessions, and it was a really indeed, the more informative and kind of learning session for everyone. I think the participants will agree with my voice.
Okay.
Thank you very much, sir, for being with us.
Yeah. Thank you so much,
Yes,
sir.
sir.
Thank you.
Thank you. Thank you.
Thank you.
Thank you.
Thank you very much, sir.
Thank you, everyone.
Thank you. Thank you very much, sir.
Thank you.
So
Thank you.
one
Thank
thing,
you.
sir. Can we have your mail, sir?
Yeah, participant, I'm also doing some kind of data analysis services. If anyone looking for your PhD consultation or anything, you can contact me. I will give my number as well as my email ID.
I'll share everything with participants, sir. I'll share.
Oh, okay, please. Thank you,
I'll
sir.
share.
Okay, sir.
Okay, you can give my email ID as well as phone number, sir.
Yes, sir. I'll
Okay.
share.
Thank you, everyone.
Bye, sir.
Thank
Dinesh,
you,
sir,
sir.
please.
Thank you very much, sir.
Thank you.
Yes, sir.
Sir.